Good morning, class 10. As we had done the proving of Pythagoras theorem and converse of Pythagoras theorem in the last videos. Today we will discuss some problems related to these two theorems. Let us start question number 1 of exercise 6.5, which is sides of triangles are given below. Determine which of them are right triangles. In case of a right triangle, write the length of its hypotenuse. In the first part, sides are given 7 centimeter, 24 centimeter and 25 centimeter. As we know that hypotenuse is the longest side in a right angle triangle. So here the longest side is 25. 7, 4 and 25. Longest side is 25 centimeter. So square of 25 is 625. Square of 24 is 576. Square of 7 is 49. So square of longest side is equal to sum of the squares of other two sides. 576 plus 49 equals to 625. So if the square of longest side is equal to sum of the squares of other two sides, then the triangle is a right angle triangle and its hypotenuse will be 25 centimeter. In the second part, sides are given 3 centimeter, 8 centimeter and 6 centimeter. Square of longest side is 8 square is 64. Sum of the squares of other two sides, 6 square 36, 3 square 9. So 64 is not equals to 36 plus 9, which is 45. So square of longest side is not equals to sum of the squares of other two sides. So therefore it is not a right angled triangle. So before moving to more questions, there is a theorem which states that if a perpendicular is drawn from the vertex of the right angle of a right angled triangle to the hypotenuse, then the triangle on both sides of the perpendicular are similar to the whole triangle and to each other. Which means in triangle ABC, if angle B equals to 90 degrees, so it is a right angle triangle. If we draw a perpendicular from right angle from vertex B to hypotenuse AC, so BD is perpendicular to AC, then there are three right triangles. One is ABC, second will be BDC and third is BDA. So all three triangles are similar to each other. Second question, PQR is a triangle right angled at P and M is a point on QR such that PM is perpendicular to QR. So we have to show that PM square equals to QM into MR. Given angle P equals to 90 degrees, PM is perpendicular to QR. We have to prove PM square equals to QM into MR. As we know that in triangle PQR, if angle P equals to 90 degree, so QR will be the hypotenuse, and if we draw a perpendicular from right angle of a right angle triangle, then all three right angles are similar to each other. As you can see in triangle PMQ and triangle RMP, PMQ and RMP, actually they are similar to each other. You can see angle PQM equals to angle RPM, angle PMQ equals to angle RMP is 90 degrees. So both the triangles are similar to each other. So ratio of their corresponding sides will be equal. So therefore PM upon RM equals to QM upon PM. If we cross multiply, PM into PM will be PM square equals to QM into RM, or we can say MR. This we have to prove. As we have done the proving of second question, you can do question number 3 also. Question number 4 is ABC is an isosceles triangle right angled at C. So we have to prove that AB square equals to twice of AC square. So it is given that right angle at C and it is isosceles also. Isosceles means when two sides of a triangle are equal. So AC is equals to BC. It is also given in the question. Given angle C equals to 90 degrees and AC equals to BC. To prove AB square equals to twice AC square. Let us start proof. In triangle ACB, since angle C equals to 90 degree, it is given So we can use Pythagoras theorem, which is here the hypotenuse is AB. So AB square equals to AC square plus BC square. AB square equals to, as it is given that AC equals to BC. So in place of BC, we can write AC. So AC square plus AC square. AC square plus AC square will be twice of AC square. So AB square equals to twice of AC square. This we have to prove. Question number 5. ABC is an isosceles triangle with AC equals to BC. If AB square equals to twice of AC square, prove that ABC is a right triangle. So it is just the converse of question number 4. Here it is given that AC equals to BC and AB square equals to twice AC square. Now we have to prove that angle C equals to 90 degree or ABC is a right angle triangle. So let us start proof. Since it is given that AB square equals to twice AC square. So AB square equals to, in place of twice AC square, we can write AC square plus AC square. As it is given AC equals to BC, so in place of AC square, we can write BC square. So AB square equals to AC square plus BC square. Therefore, angle C equals to 90 degree using converse of Pythagoras theorem, which is if square of one side is equal to sum of the squares of other two sides, then the angle opposite to first side is a right angle. Homework for today is you have to do question number 1 to question number 5 of exercise 6.5. Thank you, children.